Greetings and welcome to lesson 2.4, Solving Linear Equations. In a couple of the previous lectures, we chatted about some of the nice properties that we have: addition, property of equality, multiplication, property of equality. Both of these properties we use to solve equations. Now we're going to get a little bit more in depth in solving linear equations in this lecture. Let's start with some terminology. Linear equation in one variable is any equation that we can put in the form ax plus b equals 0, where a and b are real numbers and a does not equal 0. It's okay if b equals 0, but a does not equal 0. So here's what we're going to start doing to try and solve linear equations, because sometimes it's like, where do I start? Somebody will throw some math at you and it's like, well, it's pretty confusing. So what we're going to do is, first thing we're going to do is we're going to look to see if we need to use our distributive property to separate our terms. Next, if the fractions are present, maybe we consider eliminating the fractions by multiplying all the terms by the LCD. We're going to then combine similar terms. Once we combine similar terms both on the right and both on the left, we're going to use our addition property of equality to get the variables on one side, the variable on one side, and the constants on the other side. And again, it doesn't matter if if you choose to always move the variables to the left or always move them to the right, or a hodgepodge of that. It doesn't matter which side. It's just you want on one side of the equation your variables, on the other side of the equation you want your constants. Then we're going to use our multiplication property of equality to get all the variables isolated. And then the last thing we want to do really is to check our solution. So let's work through a problem, an example. We're going to solve 2 times the quantity x plus 3 equals 10. Again, following our guidelines on how to solve these, we're going to distribute the 2 to our x as well as the 3 on the left-hand side. So we have 2x plus 3 times 2 equals 10. Let's do the math of 3 times 2. So 2x plus 6 equals 10. Using our addition property of equality, we're going to subtract 6 to both sides. Now that leaves me with 2x equals 4. Using our multiplication property of equality, I'm going to multiply by 1/2, or in this case I can just divide by 2. Therefore our answer is x equals 2. Now at this point you want to check your answer. So you want to verify by wherever you see an x, you're going to put a 2. So where 2 times the quantity x plus 3 equals 10, does 2 times 2 plus 3, does that equal 10? 2 times 5 equals 10. Now if you noticed, I never moved the right-hand side. I worked completely down the left-hand side. And here's how we're going to do it. If we had values on the right-hand side and we had values on the left-hand side, what we're going to do is going to work down all on one side, all down the other side, and if the two sides equal the same number, then our answer that we found, our solution that we found, is verified. All right, let's try another one. 3 times the quantity x minus 5 plus 4 equals 13. Now, I have this stray plus 4 going on, so I do need to move that. I could either distribute first, or I can start moving things around. And I'm going to go ahead and start moving things around. So I'm going to move, in essence, subtract 4 from both sides. That gives me 3 times the quantity x minus 5 equals 9. Distribute the 3. 3x minus 3 times 5 equals 9. Well, 3 times 5 is 15. I'm going to use my addition property of equality and add 5 to both sides. Now I have 3x equals 24. Divide by the coefficient in front of the variable, so divide by 3 for both sides, x equals 8. Now we need to verify, does x equal 8? Wherever we see an x, we're going to place an 8. I'm just going to do the math on the left-hand side. 3 times 8 minus 5 plus 4. Well, 8 minus 5 equals 3. So I have 3 times 3 equals 4. 3 times 3 is 9. 9 plus 4 is 13. 13 equals 13. We're good. All right, here's a little bit bigger problem. 5 times the quantity x minus 3 plus 2 equals 5 times 2x minus 8, all minus 3. Okay. Now I'm going to start moving stuff around. I can distribute. I can do all kinds of stuff. I think this time around, I think I'm going to distribute as much as I can first, and then combine like terms and go from there. So I'm going to distribute the 5x, and then that's on the left-hand side. And I said 5x, pardon me. I'm going to distribute the 5 on the left-hand side, distribute the 5 on the right-hand side. 5x minus 5 times 3 plus 2 equals 5 times 2x minus 5 times 8 minus 3. I have a little bit of math I can do on my left-hand side so far. 5 times x is 5x. 5 times 3 is minus 15. And I still have the 2x here. Or, I still have the 2. On the right-hand side, I have 5 times 2x minus 5 times 8, minus 3. So I have 10x minus 40 minus 3. Now I can start combining at least a little of the like terms. So negative 15 plus 2 is a negative 13. A negative 40 minus 3 is a negative 43. Now I want all my variables on one side and all my constants on the other. I think I'm just going to move, I'm going to have all my constants on the right and my variables on the left. Again, it doesn't matter, but this is how I'm going to do it. Add 13 to both sides. That will get me 5x minus 10x equals 5x equals 10x minus 30. Let's see if I can get my mouth working right. Now I want to get all of my variables on the left-hand side, so I'm going to subtract 10x from both sides, leaving me with negative 5x equals negative 30. I need to divide by negative 5 to both sides. Negative 5 divided by negative 5 is positive 1. I have 1x on the left-hand side. Negative 30 divided by negative 5 is a positive 6. So my solution that I found is x equals 6. But I do want to check this. Now I have an x on the left and I have an x on the right. We'll want to verify that if 6 is indeed the solution to our equation. So wherever we see an x, we're going to insert a 6. So I have an x and an x, and in those two locations I am going to put 6. So now I have 5 times 6 minus 3 plus 2 equals 5 times 2 times 6 minus 8 minus 3. I'm going to do the math. 6 minus 3 is 3. So now I have 2 times 6 on the right-hand side is 12. So I have 5 times 3 plus 2. Does that equal 5 times the quantity 12 minus 8 plus 3? Well, 12 minus 8 is 4. So I have 5 times 3 plus 2 equals 5 times 4 minus 3. 5 times 3 is 15 times 2. Sorry, not times 2, plus 2. 15 plus 2 is 17. That is a 17 on that side. And 5 times 4 is 20 minus 3, 20 minus 3 is 17. So again, I worked both sides down until I saw, do they equal one another? The reason why we do that is if we start switching things around, we can actually make an error. So we just want to work both sides down and see if they do equal one another. If they do, then we're good. Okay. Now, similar to last lecture, when we're working with decimals, we can either just go through the problem, work with the decimals. That's going to be our method 1. Our second method is we can eliminate the decimals by multiplying whatever we need to get to a whole number. So let's work through the first method by just working with the decimals we have. 0.08x plus 0.09 times the quantity x plus 2,000 equals 690. I'm going to distribute the 0.09. So I now have 0.08x plus 0.09x plus 0.09 times 2,000 equals 690. Well, 0.09 times 2,000 is 180. So now I have 0.8x plus 0.09x plus 180 equals 690. I can combine the x's together and I have 0.17x. I'm going to subtract 180 from the left-hand side, bring it over to the right-hand side by subtracting 180 to both sides. That gives me 510. So 690 minus 180 is 510. So my problem now is 0.17x or 0.17x equals 1510. Now again, using my multiplication equality of multiplication property of equality. Oh yes, I can talk. You're going to multiply by the reciprocal, or remember, multiplying by the reciprocal is just division. So I'm going to divide each side by 0.17, and therefore x equals 3,000. That's our first method. To me, I'm not crazy over working with decimals. It's not horrible, but I would prefer to eliminate the decimals. So the decimals I have are 0.8, 0.08, and 0.09. Those are my decimals. What number can I multiply 0.8 and 0.08 and 0.09 by to get the both to look like whole numbers? Well, if I multiply it by 100, that should get me a whole number. But using my multiplication property of equality, what I do to one side of my equation, I must do to the other side. So if I multiply both sides by 100, both the right and left sides by 100, I should be able to eliminate the decimals. Therefore, 100 times 0.08x will give me 8x. 100 times 0.09 will get me 9. But there's multiplication in between the 0.09 and the parentheses. Because of that, if I multiply the 100 by the 0.9, I'm also doing the parentheses. So I don't have to distribute the 100 in the parentheses. Just keep that in mind. Try and simplify it. And then on the right-hand side, 690 times 100 is going to be 69,000. Now I'm going to distribute the 9x, or pardon me, the 9 to the x, the 9 to the 2,000. So I have 8x plus 9x plus 18,000 equals 69,000. Combine the x's, I get 17x. Subtract the 18,000 from the left-hand side, subtract it from the right-hand side, that gives me 51,000. Divide each side by 17, and my answer is 3,000. Now you probably still want to verify, but look, we did this 2 different ways. I got 3,000 both ways, So both in method 1 and both in and also in method 2. Therefore, I'm pretty sure my answer is correct. All right, so let's work through an example. 7 minus 3 times a quantity, 2y plus 1 equals 16. First thing I want to do is distribute the negative 3 to 2y, distribute the negative 3 to the 1. It's very important that you remember to bring that subtraction with you. So I have 7 minus 3 times 2y minus 3 times 1 equals 16. Do a little bit of the math. Negative 3 times 2y is negative 6y. Negative 3 times 1 is just negative 3. I'm going to combine the 7 and the negative 3. That gives me a positive 4. Now I have some constants on one side, constants on the other side. So I'm going to bring all the constants to the right-hand side by subtracting 4, giving me negative 6y equals 12. Divide by the coefficient of y, which is negative 6, both sides by negative 6, y equals negative 2. Negative divided into a positive is a negative, so the answer is negative. Now I'll give you this problem for you to work out all by yourself. If you want to check the solution, you can just email me and I'll be fine to check it with you. 3 times the quantity 2x minus 5 minus the quantity 2x minus 4 equals 6 minus the quantity 4x plus 5. I will give you a hint. In front of the parentheses is an implied 1. Therefore, you're going to have to distribute a negative 1 and a negative 1. And on the right-hand side, also distribute a negative 1 to both the 4x and the plus 5. Okay, so that's it. Just to recap, let me scroll up to our very beginning and just look over our strategy one more time. And maybe you can put all these parts and pieces together with some of the examples we were doing. Step 1A, distributive property if need to. And then if there are fractions or even decimals, maybe you want to get rid of those fractions or decimal. Fractions by multiplying by the LCD, decimals by multiplying by the power of 10 that you need. You're going to use addition property of equality to get the variables on one side of the equation and the constants on the other. You're going to use multiplication property of equality to get the variable isolated, which means you're solving for the variable. And then fourth is you're going to check your solution. That's it for solving linear equations. Until next time, be seeing you.